Alright friends, so on today's sloppy workbench we have a Mamaroo. I believe this is the 2012 to 2014 model. I picked it up off the side of the road. It was nice and clean. I had my wife go ahead and wash all the cloth stuff, but it was quite clean. But unit wasn't working when I found it. Didn't look like there's any visible signs of mechanical damage or anything like that. Transformer cleared initial test. So once I took it apart, the screen would barely light up. I found that there was a blacked out part of the circuit board right here. And I tried to repair it. You'll see a jumper cable, and then I tried to attach 3 other wires. The problem is I didn't know what was burned out. There's some black goop that flashed out of it, and then on this part of the case you can see that's where the damage happened on the circuit board. That's my fingerprints right in the middle. So the unit burned out. Couldn't find a replacement board. Tried different transistors totally at random to see if they would fix it. Didn't work. So kind of hating to have to trash this entire unit for a little tiny component on a board. I took a look around and kind of came up with my own solution. This interesting unit actually is quite basic in its bare principles. It moves right and left, up and down, and the nice thing about it is it runs on a constant 12 volt or up to 12 volt little electric motors. One is buried inside the mechanics of this unit, which you can find other videos on how to dismantle and repair. One of the rubber slings come off, and there's another 12 volt motor right here. And so if you regulate this voltage 0 to 12 volt, you get different speeds out of the right and left. It's a constant, so it's not a switch back and forth right and left of the motor, but it's one solid motion, constant voltage power, and the gears just keep spinning, and it's kind of a smooth mechanics. And then changing the tempo of the frequency of the two motors create different effects. So those are the 5 different settings that you can choose from. In addition, it has a little musical amp system and an auxiliary input that we're going to go ahead and bypass and make this thing analog. So for starters, I went ahead and set it up on a circuit board tester. I'm going to go ahead and show you how this works. Let's see, power on, and I have these 2 potentiometers right here connected to each individual motors, so I can regulate one, and you'll see the movement. The Mamaroo starts to move right and left. That's all it is, pure $300 spent into that unit right there. So I can increase the speed. And when you have a child on this and all the different mounting, it's a little bit heavier, so it probably goes a little bit slower than what it looks like. But I can increase it, and I can control the second potentiometer right here, analog, and start the up and down motion. And the combination of those two is supposed to replicate a mother swaying their child back and forth. So I can play around with these settings and try to mimic the 5 options that the unit lets you choose from. But my guess is if we find this thing useful, once we find a setting, we'll just have an on-off switch and just set the baby in and turn it on. But so you can do different, get kind of crazy. I feel like I would get, it's kind of like a roller coaster for a baby. But all I'm doing right here is regulating 2 dials. I cut them off completely, and the unit powers off. And it's, you can see it's purely mechanical. This is just going constantly in one rotation. Actually, interestingly, it actually has a some type of infrared positional beacon, or whatever you want to call it, sensor that reports to the board, I guess, where it is in that time and place to help out in the timing. But we'll be bypassing all of that. So we are going to use this 12 volt entry point, and it circles around the back of that circuit, and we're going to grab it off the main board. We'll probably do some kind of a temporary patch in case we ever wanted to go back, if I ever got a hold of one of these boards. And then the 2 motors actually have plug and play connector, clip connectors, and so I'm going to go ahead and clip them into a 12 volt circuit that I'm going to go ahead and test out and see if it works. Alright friends, so I'm back now. Our ultimate goal is to have, in terms of replacement / repair of this unit, to have a power switch and the 2 knob dials to control the 2 motors. on the unit itself, on the external part. I'm going to leave all the original components inside, like I said, in case I ever came across the board and wanted to replace it or repair, if I knew what the values were for the different components that were damaged. So nonetheless, I will try to find a clean area where I can drill 2 holes and insert and buckle down a little circuit board and mount the 2 variable resistors through the plastic, and try to keep it still somewhat elegant when it's all put back together. So what I've gone done right here is tested this new circuit out. It's using the Mamaroo 12-volt power supply that came with the unit. So this breadboard is the forget the side extras. This unit's off, so it's getting power supply through this jerry-rigged soldering job right here, and it follows a 12-volt circuit that you should be able to find in one of my other videos. And right now it's connected to just this one potentiometer. So let's go ahead and give it a twist. Now the first thing you notice is it's not going that fast, and I actually have the potentiometer maxed out. Unfortunately, this regulator, when I bring it down to 0, it will cut the unit 100% off. It's not moving right now. It's hard to tell because I didn't put a dial on it. I have a couple I'll end up in the end. But it actually, if you figure your 360 degrees, if it did full 360, it's a little less than that. It's only in the first, say, 90 degrees that it actually shows any regulation at all. So right now I'm about, say, 40 something degrees in, and upwards of there we're maxed out. But it's hard to tell because I've never actually seen one of these units live with a child on it to know what speed I'm trying to replicate or find. But I'm gonna go ahead and go with that. I might try a different potentiometer just for the sake of it, to test it out and see if they work any differently. This is a 5K. So just a quick snapshot to show you how much I really don't know about electronics. I've tried a 100 kilo potentiometer resistor, variable resistor, and so stronger resistance, variable, and my controlled part of the dial is actually a lot shorter range now. As soon as I start turning it, it's at its full speed. I can go all the way and it makes no difference. So I need a lower K value, and I'm afraid that's out of, don't have any more. Alright friends, hopefully this will be the final video before the finished package. We're no longer on the circuit board tester. We're actually using the actual power supply. I'm just holding it with my hands, so it'll be hard to record. Here's a circuit that I made after too many hours. Probably would have been 10 times smarter to purchase two $2 ones I found on eBay. Circuit voltage regulators. I actually had made my first circuit board over here, and I've actually cannibalized some of the parts. Did some of my custom etching on the back. You can see some old printouts on the back. It's hard to troubleshoot. You kind of have to start over from scratch if you do mess something up in the design. So then this was my second design. In the back you can see the etching and the soldering, and I had a lot of issues trying to transfer the etching design onto the copper before etching it. But nonetheless, that was the final product, and I'm just going to hold the ground to this right now. And we have two potentiometers right here that I'm going to be adding in. I'll be adding in a power switch. And if I turn those knobs, I have control, somewhat control. It's still limited. Truth be told, it's not the be-all, end-all, but it should work for the speed that it's seems to be working best on. So there I'm lowered and turned the bottom rotation off with my fingers. So I'm going to turn that up, hold that ground contact again, and so now it's going again, and I can regulate the vertical speed as well. Like I said, if this keeps giving me issues, I'll probably end up purchasing some compact voltage regulators that I found online. It won't affect the holes that I'm about to drill. To lock this board in place, I'll try to put it in the back right where the input is. Alright. Hey folks, here's the final product. We have the 2 knobs and a power switch. And actually works better than I was expecting. Here's our 11-day-old daughter Elena. She's enjoying it. And the original buttons now meaningless but still intact. Thanks for watching. Here's my crazy 16-month-old child. Lincoln, say hi. Say hi. He thinks this is pretty cool, but he's not allowed to touch it.